Hey GIS enthusiasts! Welcome back to another ArcGIS Pro tutorial. Today, we'll dive into accuracy assessment for classified images, a crucial step in ensuring your classification results are reliable. If you're into GIS, remote sensing, and geospatial analysis, hit like, subscribe, and turn on notifications for more ArcGIS Pro, GIS programming, and Python tutorials. Let's get started.
Okay, so if you have already the classified image created, you can calculate how much accuracy this one has by just going to your tools, okay, and then you can search for accuracy assessment points. So it will be create accuracy assessment points, okay, and in the spatial analyst tool, okay. So in the spatial analyst tool, you can click on create accuracy assessment points, okay, and input raster I'll be giving my classified image. Okay, so right now I just stopped classification to preview file, so I'll be setting up this preview file for my as my input for calculating the accuracy. Okay, and then I can just set my location to generate the point, so I'll just give it in a location of yeah accuracy points 1. Okay, so I'll just set the location for to create the accuracy assessment points, and the target field should be classified. Okay, because we'll be looking for the accuracy of the classified field. Okay, and then you can have okay. So now I'll just set my accuracy points as 30. Okay, so for you guys, you should take. I think it's better if you guys took at least 100 points. Okay, so 100 points it will be creating randomly on your image. Okay, and then stratified random should be selected so that it will actually try to create equal number of points in each classes. Okay, so stratified random is a sampling strategy. Number of random points you can set it as 100, so this will create 100 random points on your image. The target field should be classified, and then the location and the input is given, and if you run it, this tool will create actually, so if I given 30 here, it should create more than 30 random points in my image. Okay, so if these images are if these points are created, then we can use these points and then compare with a actual image. So it could be something like the Google Earth. Okay, so we could import these points to Google Earth and then like find out how much accuracy this one has. Okay, so we'll see that shortly. First, let this be created. That's accuracy. So when these points will be falling on some other classes, right? So it will be
Uh,
creating different points here. So we'll see which point, each point will be falling on some of other classes in here. So we'll be comparing the point falling inside here and in the actual imagery. So we'll import this data into Google Earth, and then we'll see in which place this point has fallen, and then we'll compare it with the data in the classified image. So if it's the same, so if it's water here, and then the point has fallen over water in the image, then it means that that place is actually correct, right? Similarly, we'll be comparing this for the 100 points, and then we'll be importing this to another tool which will be calculating how much it will be calculating a matrix. Okay, it will give us an or a percentage, a total percentage of how much accuracy it has. Okay, so similarly this will be creating these random points. Okay, and another thing is like my image has these black points, right? It should not have this black areas. Okay, so if this it has these black areas, then these points will be falling over those regions also. Okay, so now we have the random points. Okay, now if you check the attribute table of this point, so we'll be updating the attribute table of this point. Okay, so You see here, we have the classified and the ground truth. Okay. So if I go to the first point, I shouldn't go to the first point. Let me see. Okay. The second point, it shows it's a classified value of 2. Okay. So if I zoom over here, it's also built.
So,
Okay. Class values 1, 2, 3, 4. So just created for the value 1. Okay. So transfer is 2. Oh, okay. It was here. Anyway. Yeah, so okay, so if you see the point here, right? So this selected point. So if you see the classified is 2. Okay, so 2 it means developed, right? So if you remember for the values I gave, water 1, developed 2, 3, 4. Okay, so in here my classified is 2. So it means it's falling over developed area. Okay, and if you go to the third point, it's in 3, which means it's falling under the vegetation. Now what we need to check is we need to check this with an actual imagery, and we'll need to find out if this is actually falling over there. Okay. So we'll be updating the ground truth table. Okay. So we'll be comparing the Google Earth imagery and we'll be updating the ground truth table. Okay. So to compare this, we'll have to first convert this shape file into a KML file so that those can be uploaded to a Google Earth. Okay. So for the conversion, we'll go to our tools here and then we'll select our shapefile to KML. So we have layer to KML tool here. So I'll select my accuracy points. Okay, it is a selection. And we clear the selection, refresh it. Okay. So I am giving my input layer so that it can be converted to a shape. It can be converted to a KML layer. Okay. Then I'll just give it the output location. So and I'll just click on run here. So the layer file has been created. Now I'll open up my Google Earth. Okay. Now I'll first uh, open up my data. Okay. So for the KML layer, I have saved it. I'll go to that location and I'll just open up that data. So accuracy points I have, I will open it. So those points have been added here. Okay. And if I save that in here. Okay. So my points are created here. Now I'll need to compare these two data, right? But before that, I'll need to find out which year my data is. Okay. So if I remember correctly, the data that I used to create the composite image was over here. No, 9 centimeter. Okay. So these were the images that I used to create the composite image. And now if you see that it's taken on 2023 August 24, right? Okay, so I'll need this date, this exact date. Okay, so now I'll go over to my Google Earth, and then in here I have the historical imagery. Okay, in here I'll set my data 2023 and 8 months. For the data that you have, your data was collected in, you can set the date here. Okay, the same date. You can set the same month, but you'll need to select the same time frame of when your data was collected. Okay, so if the same time frame is selected, then it will be easier for you guys to consider it. Okay, so first in our JS, I'll go to my first point. Okay, okay, just describe the first point because it's falling over the area. Okay, so select the second point. So the second point, it's coming over classified. Classified is 2, which means it's coming over developed. Okay, now I'll just go to my same point here. Okay, so if I go over there, my point, right? It's not falling over the a classified. It's actually a vegetation area. Okay, so I'll just come over here and I'll set the ground truth as vegetation is actually 3. Okay, so I'll set the vegetation class as 3 in my ground truth. Okay, similarly I go to my next one. So next point, it is shown as vegetation. So I'll just go to my same point in Google Earth. So the third point. Okay, so third point is accurate. It's actually vegetation. So I'll set the vegetation class here, which is 3. Okay, okay. Then I'll go to my next point, which also shows that it's in the third class, which is registration. And then I'll just compare with my Google Earth. So it's actually supposed to be my fourth point, right? So this is my fourth point. I'll just go to my fourth point. Okay, so fourth point is really vegetation. So that will also be given the classes 3 in my attribute table. So this one will also be 3. Okay, are you guys getting what I'm doing here?
Yes, 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 sir.
Right? So we'll be comparing the classified and ground truth. Okay, and then we'll see if the ground classified is actually the same, right? It's actually predicted in my image. Okay, so I'll see my point. It shows us classified is 4. Okay, which means it is falling over barren land area. Okay, so I'll go to my same point in my Google Earth, which is the fifth point. So I'll select the fifth point and see where it is going. So let's see where it falls. Okay, so it is actually barren. Okay, so it is barren. So I'll set the same class as my ground truth. So I go over here and I'll set the same as right. So fourth is barren. Okay, so it was classified as barren, and then in actual the truth was also barren. Okay, but if I take the case of my second point, the class it was classified as developed, but then it was actually vegetation. Okay, so similarly you will have to update all the 100 points that you have. Okay, so when you update all the 100 points that you have, okay, after all the under points, so which means that when none of the ground truth should be -1, it should be having any of these classes. Okay, so after all these points are updated, you'll save it. Okay, and you'll come over to your tools again, and then you can search for confusion matrix. Okay, so there will be an option in your spatial analyst which is compute confusion matrix. In here you will be setting up the accuracy points, which whatever the accuracy points that you had created and then updated the ground truth values, you will be taking that accuracy points in here, and then you can just okay. So in this output confusion matrix, okay, so there is a bug in this specific version that if you give or if you change the location, okay, so if you browse and change the location, this thing will not run or this will crash. Okay, so whatever the trainers that still have done on this, just said that just give the name here. Okay, do not change the location. Only give the name here. So if you give change of the location, this might not run. Okay, so you guys can maybe check it out. If it's crashing, then you can just give out the name the next time. So you'll input the points. You'll set the output confusion matrix name, right? So this will be the name, and then you can just run. Okay, after it is done, a table will be created. Okay, so if you see the contents at the bottom, there will be a table created accuracy matrix, and if you open the table, it will show you how much accuracy you have. Okay, so right now if I see where the p accuracy and u accuracy means, it's showing 0.75, which means that the data that I have just created is has a 75 percentage accuracy. Okay, but it's not actually correct because I didn't update any of the data. Okay, because I only updated for 5 rows or 5 points, right? So if you had actually updated all the points and saved them and then created the confusion matrix, you will have an option to it will have a table like this which will actually show how much accuracy that you have. So where the u accuracy and p accuracy means, that will be your total accuracy in points percentage. Okay, so 0.75 means it has a 75% accuracy. So just make sure your data has at least 70-75% accuracy. Okay. So we know that like it's a machine learning algorithm, right? So it cannot actually have 100% accuracy. So the maximum that the minimum that we should have is at least we should have 70-75 percentage of accuracy for your classified image. So was this step clear?
Okay, sir.
Okay. So there's nothing. You just create the points and then you convert it into a KML, open them in a Google Earth, and then you just open up your attribute table in here also. Okay. So compare each point. So select a point here. Say look at the classified. Go to your Google Earth and see where that point falls. So and then update that class here. Similarly, update for all the points. After that you've done, just save the point, okay, and then go to your tool, and then you need to use the compute confusion matrix, and then in here input give your updated accuracy points, and then just give the name here. Just run. It will create a table for you, and in the table you will have the accuracy, how much accuracy your data or your classified image is. Okay.